So we're going to do a slightly more complicated equivalency here. We're going to demonstrate that not if A then B and A and not B are equivalent sentences. Now this is a much longer proof, so I'm just going to go ahead and show the left to right equivalency, and then I'm going to have to erase this in order to show the right to left equivalency. So right now we're going to try to get from not A therefore B, and we're going to try to derive A and not B from that. So our goal here is a conjunction. So there's a couple things we could do. One would be to negate this and try to show that we can get a contradiction. But generally an easier thing to do is to try to derive A and then derive not B separately. And then we can just put them together by conjunction introduction. So we're going to get this line through conjunction introduction eventually. Well, first we need to get A. And we also need to get not B. Now, there's no obvious way to get A here. So what suggests itself is that we need to assume not A and show that a contradiction is going to follow. So we're assuming not A for purposes of negation elimination. We're going to show that a contradiction follows from not A. Now, how might we get a contradiction? There only seems to be really one thing to do here, is to show that we can get A therefore B in here and get a contradiction with not A therefore B. So what we'll do is assume A and show that B follows, so that we can get if A then B, and we'll have our contradiction. So A is being assumed for purposes of conditional introduction. And this is, what I'm about to do here is kind of a general pattern. This is a trick that you'll use quite often doing derivations with this basic system. We have a contradiction here and we want to get B. All we have to do is assume the opposite of what we want. So assume not B. For purposes of negation elimination. And then we'll reiterate this contradiction into this subderivation. And then we can close it out and get the opposite of what we assumed. So lines 5 and 6 are A and not A. And we get those by reiteration on line 2 and 3. And now we can close this and we get line 7 by negation elimination lines 4 to 6. So on line 8, we've shown if we assume A, then B follows. So lines 3 to 7, conditional introduction. And now we have if A then B, we can reiterate line 1 in there to show our contradiction. It's just line 1 reiteration. And so we can close this out. And line 10 is A by negation elimination lines 2 to 9. So now we need to start proving not B, and we're going to kind of do the opposite that we did here. We're going to assume B for purposes of negation introduction. So what we're about to do here is kind of another general trick, or a strategy that you can use quite often in these kinds of derivations. We want to show that we want to do the same thing we did here and get A therefore B to contradict not if A then B. Okay? So we're going to assume A. We want to show that B follows. So we're assuming A for conditional introduction. Well, we have B right away by reiteration from line 11. So on line 14, we have if A then B, or A therefore B. Line 12 through 13, conditional introduction. So once again, we reiterate line 1 down there. And we have our contradiction between lines 14 and 15. Line 15 is just reiteration of line 1 again. Line 16, we can close out this subderivation, and B got us into a contradiction, so we can conclude not B. Negation introduction, lines 11 through 15. And now we can just put 10 and 16 together on line 17. Conjunction introduction. So that completes the left to right direction of the proof. We have the left to right equivalency. Now we need to start another derivation going the opposite direction, going right to left. Fortunately, this direction is a lot simpler. We're trying to get a negated conditional, so what we should do here is assume the opposite of what we're trying to prove. So we're going to assume if A then B. So what we're trying to do here is show that A therefore B gets us a contradiction, and then we can negate it. So we're assuming it for purposes of negation introduction. Okay, so what to do here? Well, kind of an idea here is that we can get a contradiction by getting either B or A. Or sorry, either B or not A. We can get a contradiction with line 1. Well, if we have A, we get B, which is a contradiction, so then we can get not A and get a contradiction with this, and then close out this subderivation. So that may have sounded a little complicated. Let's go ahead and run through it. We assume A, okay? What we're trying to get out of this is not A. So we're assuming it for purposes of negation introduction. On line 4, we get B, conditional elimination, lines 2 and 3. And now we can reiterate not B down, or not, sorry, not reiterate, but we can use conjunction elimination to get not B from line 1. So we have B and not B together, and we can conclude not A from lines 2 to 5. And now we just need to bring this A down in here. Again, we're going to use conjunction elimination on line 1. And we have our contradiction, assuming if A then B led to this contradiction here. So line 8, not if A then B, from lines 2 to 7. Negation introduction. And now we've proven the right to left equivalency, and we're done with this proof of this equivalency.